you know that g of negative 5 is going to be equal to the starting position, like the integral, so the starting position, like this, correct, plus the integral from negative 5 to 0 of g prime of x dx. Well, what is g of 0? On the chart, what does it tell us g of 0 is? On the chart, what does it tell us? That it tells us g of 0 is 1. So this is 1, and then do we like negative 5 to 0? Do we like saying negative 5 to 0? Well, actually, we do. Excuse me, it's my fault. This should have been 0 to negative 5, like this. Yeah. Do we like 0 to negative 5? No, so we flip it, but when we flip it, what happens to the integral? It becomes negative, right? So then what does this mean? This means the area under the curve from negative 5 to 0, right? From negative 5 to 0. So you have to go look over here, and you have to figure out what's the overall area. Well, it tells you this is 4, negative 2, and 1. Add those up, and what do you get? Add those three numbers together, and what do you get? 3. So it's going to be equals 1 minus what? 1 minus 3. Sorry, I went too far. 1 minus 3 is what? Negative 2. So the first one is negative 2. Then all you do is you calculate how much you're increasing at each step. So Nick, look at the graph here, and if you go from negative 5, which is right here, if you go from negative 5 to negative 3, how much area do you add if you go from negative 5 to negative 3? How much area do you add?
Those are just
4. You see the 4? It's right there. It says 4, right? So you add 4 to where you were. Plus 4 is 2. And then you're going from negative 3 to negative 1. You're adding how much? Negative 2. So it goes down 2 to 0.
okay.
You do it that way. You scan from left to right. You scan from left to right. The other way right here is using the fundamental theorem of calculus. If you want to know what the area under the curve is from A to B, you need to evaluate g of 0 minus g of negative 5. With me so far? Right?
Yeah, but how do we know that?
How do we know this? Well, look, the integral from negative 5 to 0 is 3. And on the chart, what does it tell you? It tells you that g of 0 is what? On the chart, what does it tell you g of 0 is? 1.
Right.
You do this one, which was adding up those three numbers, 4, negative 2, and 1. That's where the 3 comes from. The 1 is on the chart. Well, you subtract it here, and look what you get. 2 equals negative g of negative. Oh, look, you can solve for it right there. That's another way to do it. That's another way to do it. What was the key letter here in this rule, this property at the top? What was that key thing? Do you remember what I highlighted before? What was the letter that was really important? B. You need to link these two together. The other ones are also important as well. It starts at A, so where does it have to end, Nick? If it starts at A, where is it ending? It starts at A, where does it end?
C.
Yeah, so C has to be the same. And then the other key thing is kind of the most important thing, but it's so important we don't really mention it. What has to be the same for each of these? Yeah, you better have the same f of x or it doesn't work at all. So that allows you to pull integrals apart or put them back together. What about here? What does this one effectively allow you to do? What does this allow you to do? Factor out. It allows you to factor out a constant. How do you tell if something is a constant with an integral? Well, what does the dx tell you? The dx tells you what you're integrating with respect to. So if you see dx, anything besides x is a constant. If you saw dy or dz, anything besides those letters would be constants. So can you factor out constants? Yes, you can. You can also put them back in if you want to. What does this one allow you to do, Connor? What does rule C allow you to do? To evaluate to be, I think it was 21. 21 feet north. So that means in Connor, or whoever was speaking right there, 2 seconds, the person is now at 21 feet north of where they started. V of t, how do you find V of t given S of t? You do what? You take the derivative. What was it? 4t plus 4. So evaluate and interpret what are 4 ways. So list out the ways first. It's not asking for minute differences in like algebra. So first would be using the fundamental theorem of calculus. That would be integrating by hand or, in general integrating by hand, but using the fundamental theorem of calculus. That's one way. What's another category? You could also use your calculator. And what's another way you could do? And I would say there's at least 2 ways to do it. You're using your calculator. And what's the last way you could find the area under the curve? What's the last way you could do it? You could graph it, right? The thing about it is the velocity graph, what kind of graph is that? That's a what? That's a line, right? Let's see if I actually have this pasted in still. That's the tags. Never mind. So for FTC, for using the fundamental theorem of calculus, the integral from 0 to 2 of v of t dt, that's going to be s of 2 minus s of 0. What is s of 2? You already figured it out. It's what? 21. And how do you figure out s of 0? Plug 0 in, what do you get? So that's 16. So that's using FTC. That's the first method. What about using your calculator? That would be like math 9, right? If you do math on it, will come out to be 16. You could also use the Riemann sum program on your calculator. If you're going to do a really accurate estimate, what value needs to be really high? N value, the number of rectangles. Have you accidentally plugged in like too many, a number that's way too high into that program?
Yeah.
What happens? Yeah, you did 1,680, and you're still like, why is it taking so long? Like, well, you just threw a lot of things at it, which still blows my mind because it shouldn't take that long. Like, I don't know why the calculators are the same speed they were 20 years ago. It's really weird. Even when you run it on a computer, which is like literally a billion times more powerful, it still takes a while. It's really weird. It's like emulating it too accurately. It's like, we're going to be slow on purpose. So the third method would be make a graph. And when you make a graph of this, it's a line, and you don't have to use the same scale. It starts at what, 4? And it goes up, right? And you need to go to 2. What's the equation for that line? It's v of t, which was what? 4t plus what? 4. So what's that point right there? What's that point right there? 2 comma what? That's 0, 4. What's that other point? Oh, come on. No. Come on, kids. Yes, it's 12. Plug in 2 into this. What do you get? 12. So how do you find the area of this shape right here? There's a couple of ways you can find the area. What's one way you can find the area right there? Yeah, a rectangle and a triangle, absolutely. There's also a formula for a trapezoid like that. It's the two heights, half of the two heights times the base. What's the height right here? 4. What's the height right there? 12. 1/2, I call it height 1 plus height 2 times the base. What's the base here? 2. So that's 1/2 of 4 plus 12 times 2. So that's what? 1/2 times 16 times 2, which is 16. So does it work out to be the same thing? It does. Now, when they say 4 ways, that would be math 9 and maybe Riemann sum, if that makes sense. Okay, let's move on. You'd already started looking at the next ones, I think. What's the new word that's on the board? Indefinite. Why is it called indefinite? Someone over on that side of the room. Why is it called indefinite? What's different about these integrals? What's new about these integrals? They don't have an A or B. They don't have the limits of integration. So these aren't going to be numbers. Definite integrals are numbers, or they contain whatever's in the limits. These are going to be functions. This is effectively asking the derivative of what is 2x. Can someone answer that for me? The derivative of what is 2x? X squared. And what do you have to add to that? Why do you have to put a c here? We talked about this before. Why? Because anything could be there, right? What's the derivative of a constant, Liana? 0. So it could be anything. What about this one right here? The derivative of what is 4x? Connor, the derivative of what is 4x? Okay, so we could think it's x to the 4th, but if you take the derivative of that, oh, what's the derivative of x to the 4th?
4x.
Cubed.
Oh, probably, sorry, 4 cubed.
Okay, so is that the integral? It isn't. You're close, you're getting there. Anybody want to help him out here? Zach. You know it has to be x squared because the power has to go up 1, but you want a 4 in the front. When you do the derivative of x squared, what gets dropped to the front when you do the derivative of x squared? 2, but you want it to be 4, so what else do you plug there? Oh, 2. And what goes plus what? C. What is the derivative of 2x squared? 4x. Correct. So you have 3 pieces here. Does that change much? No, you can do each piece. What's the derivative of 1? No, you're right, excuse me, I asked the wrong one. The derivative of 1 is 0. What's the integral of 1? X. Hey, what's the integral of 2x? X squared. Oh, and hey, what's the integral of 3x squared? X cubed. And then there's a plus c right here. So you can do each piece separately. That's what that rule at the beginning was helping you with. You can do each piece separately. This one is set up really nicely. So in general, though, what's going on here? Let's say I asked you, what about this? 2x to the fifth. What's the integral of that going to be? What's the indefinite integral of that going to be? First thing you need to answer is, Kira, what's the power of x going to be in the integral? If that's the derivative, 2x to the fifth, what's the integral power going to be? So it's going to be x to the sixth, right? Yeah. But if you just did x to the sixth, the derivative of that is 6x to the fifth. So what do you need to put out front? What's the coefficient on this one going to be? What's the coefficient going to be? 1/3. What? Exactly, it's going to be 1/3. Why did you say 1/3, Connor?
Because that multiplied by 6 gets you 2.
Exactly. So what's the generalization here? I'm going to change 1/3. What's another way you could write 1/3? 2 over. So let's look at that. Where's the 2 coming from? The 2 is the original what? Coefficient. So there's the 2. Hey, and then what do you do with the power here? Instead of 5, what does that 5 become? You add 1. You add 1, and where does it go? Oh, there they are. So is there a general pattern here? Absolutely. Look at that general pattern and then tell me, let's say it was 3x to the 7th dx. What's that going to be? 3 over 8x to the, done. Plus what? C. Plus C. So the generalized form, it looks really complicated, but look what it's telling you. If it's the nth power, what happens? You change it to what? N plus 1 and n plus 1 because you need it to cancel out. And what did I tell you if you have a coefficient in front? What can you do with that coefficient? We just talked about that. What can you do with that coefficient? Yeah, it just goes in front. Does A have anything to do with the rest? No. You can factor it out. So where does that go? It just goes up there instead of the 1. What's the coefficient right here, right now? 1. That's why it's 1. Oh, it's different. Oh, it's just A. It doesn't change anything. This is how you integrate polynomials. You do each piece. Integrating polynomials will go very quickly. Are there many other types of functions out there?
Yeah.
There are many other types of there are many other types of functions out there. We're going to learn how to integrate them next, but for right now, you'll get really, really good at integrating polynomials. So try this one for me right here. Try these two, actually. Try those. And can some of those fractions be simplified right there?
Yeah.
But why didn't I simplify them, Jen? It shows what? What does it show? If I don't simplify everything, it shows the pattern, right? Yeah. All the coefficients stay the same, right? You have 3, you have 5, 2, well, negative 5, 2, 8, and the 1, right? The 1 right there. And then what happened to all the powers? They get incremented by 1 and placed in front and below. That's it. That's it. So to do this one without a calculator, you need to first find the indefinite integral. Nick, what's the indefinite integral here going to be? What's this going to be equal to? Something. Derivative is that. The derivative of what is 3x squared plus 2x? The derivative of what is 3x? If you do the derivative of 3x to the 5th over 5, the derivative of that is you drop a 5 to the front, and then it's 3x to the 4th over 5. What cancels there, Nick? What cancels on this? Yeah, so the 5's cancel, leaving you with what? 3x to the 4th over 5, which is exactly what you want, right? Sorry, the 5 goes away, sorry. 3x to the 4th, which is exactly what you want right there. The derivative of that is this. The derivative of that is this. Whatever the power is, so if it's ax to the n, when you do the integral, you end up with a over n plus 1, x to the what power? N plus 1. You increment the power by 1. So try this one for me. Do b for me right now. Integral you need to work with on this one.
1/2 x to the 4th.
Yeah, so you had 2 over 4 x to the 4th, right? Plus what?
Plus 1 over 2x.
Yeah, plus c. From what to what?
2.
Yeah, exactly. And now you just have to be careful about plugging those numbers in. Now you just have to be careful about plugging those numbers in. How many people are in the process of doing that right now? Be careful. So you can finish that one, and then while everybody's finishing it, do c.
0 to 4.
Yeah, from 0 to 4 of what function?
2x squared plus 1.
Exactly. That's it. So then, because that's a polynomial, you can do that by hand now. Because that's a polynomial, you can do that by hand. Everybody try that now as well.